Okay, this is where we left off on this particular example right here. Now, I did want to point out to you in the conversation that I had with you, I shouldn't say conversation, you weren't talking back, or maybe you were talking back. This diagram that I showed you with the alternating sequence that's going back and forth, okay, we can think about values. Now, this diagram that I showed you is about a sequence of values. The sequence diverges in this kind of pattern, and sometimes sequences do this kind of thing where they're alternating back and forth, but they're getting closer and closer and closer and closer and closer to something. But that's more of a discussion about sequences. When we talk about series converging and diverging, we don't normally have such an alternating pattern. We could, especially if the multiplier was a negative number like -2 or -3 or -5 or -17. In other words, the absolute value of the multiplier was greater than or equal to 1. That's where we get into this divergent situation. So we can have them alternating and getting wider and wider and wider, although you're adding terms, so that would definitely slow that alternating stuff down. If you're adding a positive and a negative and a positive and a negative and so forth. But we talked about in the video about these 3 convergent series, and we decided they were convergent because of this. The absolute value of the multiplier was less than 1. That's the only time you can use the infinite geometric series formula. And we also decided that letter C was divergent for what reason? Something to do with this thing in here. What is pi over 2 approximately? Come on, pi over 2. 3.14 divided by 2. We don't need a calculator. We can use our brains. What's half of 3? 1.5. What's half of 0.14? 0.07, right? And so that would make 1.57 approximately, right? Do you know if that's bigger than 1 or smaller than 1? It's bigger. So don't you see the idea that it's getting uncontrollably bigger, each one of the terms, and you're adding up a bunch of terms that keep getting bigger? So, of course, the overall series is not going to converge. If you keep adding bigger numbers, because the multiplier is, the absolute value of the multiplier is bigger than 1. Okay, we, in the previous video, did the formula for letter A. So let's do B and D. Okay, so here we go. We got letter B here. We've already decided that the absolute, you can ask yourself this question: is the absolute value of -4/5 less than 1? That's the question you want to ask yourself every time. And if you say the answer is yes, then you better be, you're agreeing to the fact that it converges, right? That's agreeing that it converges. And then you are using the formula. First term over 1 minus r. First term over 1. I guess I wrote it up here. I don't need to write it again. We'll just use the actual numbers. Now, I will not try to trick you like what I see in letter B here. What do you plug in first to find the first term? Normally, we would want to plug in a 1, right? That makes a whole lot of sense. If you want the first term, you plug in a 1. But that's not what this thing says. So I promise that I will not try to trick you with something like this. What do you have to plug in here to find the first term? That's weird. So if you plug in a 0 right there, what do you get? Negative 4/5 to the 0 power. Anything to the 0 power is a big fat 1. Yes, the first term is a 1. Okay, you guys have enough problems the way it is with all of the things that are going to happen on this test between matrices and then switching gears and going into the sequences and series stuff that I won't try to throw that extra headache at you. But the first term we just figured out was a 1. And the multiplier was negative 4/5. Do you know that I have a lot of people that decide to put positive 4/5 into it, and they lose? Why do you think they come down here to the bottom of this and put a positive 4/5 right there? Because they ask themselves this question: is the absolute value of negative 4/5 less than 1? They said yes, and somehow in their minds they still have this number. So they just take it and throw it in the formula. Just remember, if the multiplier is negative, keep the negative. Don't lose it when you try to find the sum. Okay, so what do we have here? 1 over. Let's see here. That does become a plus. We know that. So what is 1? Don't reach for a calculator. What is 1 plus 4/5? And don't say 1 and 4/5. 9/5. Oh, you make me so proud. Thank you. Right? For those of you who don't remember that trick, that's 1 times 5 plus 4 like they taught you a long time ago. Okay. Now, what is 1 divided by 9/5? Don't need a calculator. Here, I'll even write it out in maybe a different fashion so that maybe it might ring some bells here. 1 divided by 9/5. What do you think? What? 5/9. Thank you very much. Right? Remember that whole thing in middle school where they changed it to multiplication? And you know what? I love the fact that you just used that word, reciprocal. Anytime you're looking at an SAT, ACT, and they throw one of these things at you, 1 over a number, they're talking about the reciprocal. Okay, now let's do letter D. What's the multiplier? You can see up at the top of the screen, we got 1, 1/2, 1/4, 1/8. What is the multiplier? Any term divided by the previous term. Any term divided by the previous term. What was that over there? We got 1/2. That's true. 1/2. Oops. Right? And literally, I'm hoping you took 1/2 and divided by 1 if that's, if you needed to figure out what the multiplier was. Is the absolute value of 1/2 less than 1, yes or no? Yes, that's how we decided that it was convergent. So the series converges. Therefore, I must use the infinite formula. Oh, by the way, if the series diverges, what is the sum? There is no sum. And don't tell me because I left it blank, that's what I meant. You need to write down there is no sum. You need to tell me, hey, it cracks me up. Well, not really cracks me up. It hurts me down deep inside when a kid writes diverges 45. And I'm like, how does it diverge and have a sum at the same time? I don't know. It's magic, I guess. Okay, you need to figure this out. Find the first term over 1 minus r. Show me what you got. First term over 1 minus r. Trust me. That's a huge thing. It's 50 cents going to $1. Now that should be a minus. 1 minus. And the only reason this was plus is because we had 1 minus -4 cents. Remember that? Up here I had, oops, that's not what I wanted. We had 1 minus -4/5 on that one on the right side, and that's how we got the plus. But the formula is 1 minus r. First term over 1 minus r. There's a famous joke that goes with this particular question. Famous in the math world anyway. An infinite number of mathematicians walks into a bar. The first mathematician walks up to the bar and says, "I'll take a beer." The second mathematician says, "I'll take half that." The third mathematician says, "I'll take half of what the guy before me got." The next one says, "I'll take half of what." The bartender pours how many beers? Say it out loud, folks. 2. Smart bartender. He figured out, we're adding up all of these. We got 1 beer plus a half a beer plus a quarter of a beer plus an eighth of a beer plus a 60 plus a 32nd plus a 64. Figured out it was 2. Just like you did. Yep, that's a great joke. I like that one. Oh, yeah? I tell all kinds of jokes, man. Most of the time I'm making fun of myself. Okay, how do I convert a repeating decimal? Now, this is a specific type of repeating decimal. There are lots of repeating decimals out there that don't fit the pattern that we're showing you. Okay? And we would probably handle them a different way. But this type of repeating decimal can be looked at as a geometric series. So you've got 0.234 repeating. 234, 234, 234, 234, forever and ever and ever. So we can look at this as 0.234 plus 0.000234 plus 0.00000234. I can't write a full. And on and on and on. If we do that, what's the multiplier? What are we multiplying to go from one term to the next term? 0.001. How'd you figure that out? Any term divided by the previous one, right? Any term divided by the previous one. Okay. Plus it says so right over here. Okay, now, first term over 1 minus r. First term over 1 minus r. That's 0.234 over 0.999. I like this version right here. Now, yes, you can reduce that one to 26 over 111. But I think it's kind of interesting that 0.234 repeating is 234 over 999. What if we looked at 0.56 repeating? That would be 0.56 plus 0.0056 plus 0.000056 plus ... What's the multiplier in that particular situation? Point what? 0.01. Any term divided by its previous term will give you that. Okay. Figure out what that fraction is. It's an infinite geometric series. First term over 1 minus r. First term over 1 minus r. Yes. 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 Okay, so in this case, you multiply by 100. I did mine by 1,000. That's how I got the 234 and the 999. Sure, you're going to multiply yours by 100. Alright, so you get see, I did mine by 1,000. That's how I got 234 over 999. Do the top. Yes, that's exactly right. Yes, that's true. That's true. Sorry, it's just glare off the glass. Okay, perfect. Now, is that kind of decimal point? Did you multiply top and bottom by 100? See, I multiplied the top and bottom of mine by 1,000. Move that decimal over. Okay, so several of you, at least on this side of the room, had the sum of the infinite geometric was 0.56 over 1 minus 0.01, and you got 0.56 over 0.99, but you multiplied yours, top and bottom, by 100, and got what? 56 over 99. Huh. 0.56 repeating is 56 over 99. What about 0.8 repeating? That's 0.8 plus 0.08 plus 0.008. What's the multiplier? 0.1. Can you guess what you think the fraction might be? 8 over 9. Do you think that's true? That's true. It does. Now this doesn't happen for every single repeating. I mean, there's lots of other patterns out there that don't fit this. This is a one-digit repeating pattern, or a two-digit repeating pattern, or a three-digit repeating pattern. We are not talking about something like this. That's a different ballgame. Yes, we can do the math and figure that out. Okay, but that doesn't fit this pattern. But you're right, that one was 8/9. Okay, it's time to practice. All right. We're doing homework, so those of you not writing things down, I don't quite understand that thought process since we're working on this together. I know some of you are getting ready for 8th period, but no, not today. Okay, question 1. Write each using summation notation. Now in Algebra 2, we would have told you what the pattern was, but we're not telling you. You have to figure out, is it arithmetic, is it geometric, or neither? Maybe I should zoom in. I got 1 vote for arithmetic. Okay, we got a couple votes now. That's good. We're adding? What are we adding? Well, don't tell me we're adding. I know it's a series. In a series, we always add. But if you think the difference between the terms is constant, like an arithmetic series sequence, then yes, it would be arithmetic, which is based on addition. I do understand that. And you said 6? All right, good. How many terms are there? See, in summation notation, we have to start with a 1 on the bottom, but we have to tell it what the top term is. And folks, it's not a 53. If you think this is arithmetic, then you better be using an explicit formula to figure out which term 53 is. There are not 53 terms in this particular series. And yes, you do need to show me the work. You need to be using the explicit formula, not trying to guess and check. You're not going to get credit if you think guessing and checking is the way to go. I mean, for crying out loud, you're given the formulas, might as well use them. So use it. Figure out how many terms there are. You can tell what the first term is. You told me what the common difference is. You're looking for the one that's labeled 53. The only thing you don't know is what n is. That's probably what you're going to solve for. I like how you said it. Don't put an equal after that. Okay? So, yeah, just take the equals 53 off there. Now, if you are separately doing that, okay, so in other words, in the notes, remember I showed that we would put an explicit formula in here. You did that correctly, okay? But separately, you need to figure out what that number is on top. Because you don't want to say that the sum is equal to 53, because we would have to use a formula to do that.
Would you use the explicit formula separated from the 550?
Correct, correct. We'd have to use the explicit formula separately.
I'm mostly
okay. So, -7, we got a 6. We're not trying to find the first term. We're trying to find which one 53 is. So over here, we need to be putting in a 53. Oops, sorry. Almost lost it there. What should be going in the place of a sub n? 53. You know the first term is -7. You know the common difference. You're trying to find out what n is. It's true. So inside here is going to be our explicit formula. So those parentheses up there are going to have explicit formula in them. So hopefully you were able to figure out. You got n minus 1 equals 10. Oh yeah. Okay. That's good. Nothing wrong with that when it works right. How many terms did you get? Let's see, I think that would be -13. 13 sides. So if you added the 7, you would get 60. Now I know some of you, a lot of you distributed the 6, and there's nothing really wrong with that. I'm not a big fan, but that's okay. It still will work. So I got n minus 1 equals 10. What does that mean about n? If n minus 1 is equal to 10, then n has to be 11. So we have 11 terms here, folks. And no, I'm not going to make it that small for those of you who think that you're going to try to guess and check. No, I'm going to make it a lot bigger. Yeah, or bigger than that. Now, what explicit formula would you put inside here? We know that this has to be an explicit formula, so what are you going to put in there? -7 plus 6 times what? Oh yeah, we already had it. We had it right down here. All we had to do is throw it in there. You do not need to simplify it. If it like down deep inside hurts you not to simplify it, then go ahead. But if you don't, if you're okay with leaving it like that, then go to the next question. Jump down to 5 for a second. Well, maybe we should just do 3, just because it's not that far away and we need to get it done. Okay, so we've got 1 plus 4 plus 9 plus. Let's just leave it like this. I think they get a little bit confusing by the way that they have written it. Is this arithmetic? Are we adding the same number every time? No. Are we multiplying by the same number every time? No, this is not arithmetic or geometric. What pattern? You've got about 20 seconds to figure it out. What pattern are we following? Okay, talk to your neighbors right now and figure out what pattern this is. Talk to each other and see what pattern you think is going on here. Well, it's definitely equal. We're not adding and we're not multiplying. So we need to figure out what pattern. See, we're going to plug in a 1, we get 1. When we plug in a 2, we get 4. Plug in a 3, we get 9. I'm guessing if we plug in a 4, we get 6. 5. And you can kind of see that in the charts, but they're a little bit cryptic about what's going on. That kind of, I don't like the way they've written that. Okay, so when we put in a 1, we get a 1. We plug in a 2, we get a 4. We plug in a 3, we get a 9. We plug in a 4, we get a 16. Plug in a 5, we get 25. What are we doing? Squaring, right? Right? That's not arithmetic. That's not geometric. They're squaring it. Well, there's no common difference here. This is not arithmetic, so there is no D. When you see this right here, what are you going to put on top? Say it louder. Ah, that's right. It's an infinite one. Now, to be honest, the way they have written it, they have a stopping point. But I don't like the way they've written it, okay, because it's confusing to a lot of you. Truth be told, they're saying this, n equals 1 to n plus 1. This is what they wanted you to write, because the n plus 1 is the stopping point. What the heck is n? Where does it stop? So I didn't like the way they kind of worded that one. I would not be that cryptic on a test. Okay? That's why I kind of modified question 3 so you would look at it in something that's a little bit nicer fashion. Okay, question 5.
Wait, what's the exponential function?
When you say exponential function.
The thing that you label as the exponent.
Oh, the explicit formula? This is the explicit formula. And it's not arithmetic and it's not geometric. That's why we had to analyze it and see what pattern we had. It was just we start with a 1, you square it. So this is really, we had 1 squared plus 2 squared plus 3 squared plus, they're just doing this each and every time. Okay, and they just keep taking the value of the term and squaring it. We're focusing more on arithmetic and geometric than we are those. Okay, question 5. Okay, write the summation notation for this. Show me what you got. Summation notation for number 5. Write it down now, or is there? Do you take one? Like every 5th, every 10th day? When there's a full moon? Okay. You must decide if it's arithmetic or geometric. Yes? Okay, we always start with the first term, so n equals 1 better be on the bottom. So n equals 1 because we're always starting with the first term. I like how I chose infinity for the top. I don't know where it's stopping. Alright, so now I need the explicit formula. What type of series is it? Geometric, so I need an explicit formula for geometric sequence. Yes. Okay, alright, so you do the notes in 2 days. Okay. Alright. Check that one off for the month. Okay. N equals 1 to infinity. Hopefully you got that part, because we're starting with the first term. So if it makes sense to you folks, I don't think that number down there is ever going to change. When you're writing the summation notation, we are always going to start with the first term. Now, that doesn't mean you're plugging it. I don't want to see somebody put a 6 down there, because that means you're starting with the 6th term. We're not starting with the 6th term. We're starting with the first term. So that's where that 1 comes from. Inside here needs to be an explicit formula. And what kind of series are we dealing with? This is geometric, right? And if it's geometric, what's the multiplier? -2. Any term divided by the previous term. Okay, so at this point of your career, you should probably know how to write explicit formulas for geometric. And the first term is 6, and the multiplier is -2 raised to the n minus 1 power. Sorry, my parenthesis kind of got, I'll move that over a little bit. And then I'll answer your question. Yes.
So, how did you get? Did you go through it?
Sure. So do you understand how we decided it was geometric? Okay, because going, if I think this is arithmetic, then it would be going down by 18. But if you go down another 18, or I should say, yeah, going down another 18 would not get me back to positive 24. So if I think that this is arithmetic, you went from a 6 to a negative 12, you dropped 18 units. You're not going to drop another 18. Well, if you do drop another 18, you'd be at negative 30, not positive 24. So one of the dead giveaways is you have a positive negative thing going on. And because you're alternating signs back and forth, it has to be a multiplier. And not only does it have to be a multiplier, it has to be a negative multiplier. So if you take any term and divide by the previous term, you'll find out that the multiplier we're dealing with is negative 2. So if you take negative 12 over 6, or if you take 24 over negative 12, you're going to find out that you get negative 2 each time.
So, and what's the first?
Well, you have to know what to plug in. Okay, folks, tell me how I'm going. If you saw this on the street, okay? If you saw this summation notation somewhere, would you know what to plug in first in order to, like if I asked you to write out the first 5 terms of this series, what would you plug in first to find the first number? You would start by plugging in a 1 because it tells you on the bottom that we're starting with the first term. So literally I just plug in a 1 and that's how we got the 6. And then I plug in a 2. That's how I get the next term, which is negative 12. And then I can plug in a 3. And then that's how I get the next term, 24. Okay, so all we're doing is going backwards. I'm giving you the series and I'm saying, what summation notation did it come from? And so we're working our way backwards by...
Please disregard this, or excuse this intrusion we do have after school.
Disregard it. Shut up. Sorry, that's recorded. Oh my goodness. I probably should. Okay, so we're starting with the series down here, and we're being asked to write it in summation notation. In other words, write it in shorthand form. So the big Greek letter capital sigma is telling me to add up all the terms, and I'm starting with the first term. But see, the ... is telling me that I don't know where it stops, so that's why I've got infinity on the top. All right? Oh, I modified it a little bit. It's supposed to be infinity because I modified it. I took off this thing at the end and just looked at it as 149, ... I did that is confusing right here, in my opinion, the way they have written it right there. So that's why I ignored it. Okay? And then so the only part in the parentheses is left is what kind of sequence formula are we dealing with? It's geometric because it's multiplying by negative 2. And so all I had to do is come up with that geometric formula. First term times multiplier to the n minus 1 power. Okay.
And my question is, why is n? Why did you write it as first versus n?
Oh, just so that you understand that the n value is the number. When I say first term, second term, third term, fourth term, fifth term, those are the numbers that you plug in for n. 1, 2, 3, 4, 5, 6, 7, 8, and so on. But when some kids look at this and they put a 6 down there. They put n equals 6 because they see a 6 as the first one, and so they think that's supposed to go at the bottom. Well, that would mean we're starting with the 6th term, and I don't want to start with the 6th term. I want to start with the first term. The formula generates the number 6 when I plug in a 1. So I'm just trying to show you what some people do. Okay, we'll practice the next 2 days and test.